Our next question is cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A should be equated to sin A plus cos A. We have some tan terms in left hand side and it is a complicated expression, so consider that left hand side expression. So I want to write a cos A divided by 1 minus tan A. I can write sin A by cos A like that. In the second term also we have sin A by 1 minus cos A by sin A, which is equal to, by taking LCM in the denominator in the first expression and second expression also, we will have cos A divided by cos A minus sin A whole divided by cos A. This is the first expression, first term, and in the second term you have sin A divided by sin A minus cos A divided by sin A. So we have some rational expressions in the denominators, so just reciprocate that one. You will get this cos A will be reciprocated to the top, so that you will get cos square A on the top in the numerator of that first expression, and denominator you have cos A minus sin A plus, here also sin A will be reciprocated to numerator, so you will get a sin square A on the top divided by, and below you have sin A minus cos A. Here in this expression you have, seems to be a common denominator, but not the same, seems to be common denominator, because if you take minus in this expression, like if you take minus here, sin A minus cos A, if you take minus 1 as the common, so then this term will be reversed like cos A minus sin A, which is having a negative sign before that, so that negative sign will be multiplied with this plus and you will get minus there. So you have cos square A divided by cos A minus sin A, so here minus sin square A divided by cos A minus sin A. So what we did, we have taken minus in this expression, minus 1 as common in this expression, and multiplied that minus 1 here like at plus, so that you got minus at the middle, and the term is reversed and seems to be same in the denominator like this. So you have, by taking LCM you have common LCM, so common base, so that is cos A minus sin A. Since the both are having same denominator, so top expression will be added like cos square A minus sin square A. So on top you have a square minus b square format, so I want to split it like a plus b into a minus b. So it is cos A plus sin A into cos A minus sin A whole divided by cos A minus sin A. So you have common term, let's cancel it, and the what is the remaining thing, cos A plus sin A, which is the RHS side, hence it is proved. Our next problem is cos cube A plus sin cube A divided by cos A plus sin A plus cos cube A minus sin cube A divided by cos A minus sin A, which should be equated to 2. So here seems to be complicated expression on left hand side. So if you observe left hand side clearly, what you will see here, you can see a cube minus b cube or a cube plus b cube terms. So if you know the expansions from algebra, like for a cube plus b cube, you will have a plus b into a square minus ab plus b square, and even a cube minus b cube is equal to a minus b into a square plus ab plus b square. So these are the expansions from algebra. So now use the same rules here. So your cos cube A plus sin cube A can be written as cos A plus sin A into cos square A minus cos A sin A plus sin square A divided by cos A plus sin A. And in second term, from second term you have cos A minus sin A into cos square A plus cos A sin A plus sin square A whole divided by cos A minus sin A. So these two gets cancelled and these two gets cancelled. So the remaining thing is cos square A minus cos A sin A plus sin square A plus this expression cos square A minus cos A sin A plus sin square A plus here also you have cos square A plus cos A sin A and plus sin square A. So this plus cos A sin A and minus cos A sin A gets cancelled. You have cos square A plus sin square A which is 1 plus another cos square A plus sin square A which is 1, which you will give 2 as answer. So the next question is tan A divided by 1 minus cot A plus cot A divided by 1 minus tan A, which should be equated to secant A into cosecant A plus 1. This is also same as the previous one. There we used sine and cos. So here seems to be these are reciprocal angles. So I want to convert all the things into tan. So here tan A divided by 1 minus cot A, I can write to 1 by tan A plus let this cot A be as it is divided by. So here I want to take minus as common from these expressions so that I will have minus of tan A minus 1. So my main intention is to take the to bring the common denominator so that my further calculation will become easy. So here which is equal to, so by taking LCM and reciprocation you will have tan A into this tan A will be reciprocated to top, so you will have tan A on the top again divided by this is tan A minus 1 and here minus cot A divided by this is tan A minus 1. So here how do we got minus? So whatever minus that you brought here as common, that will be multiplied with this central expression so that you will get minus there. So now again if you take LCM in these two expressions you have common denominator so that the main LCM will be tan A minus 1. So on the top you have tan square A minus cot A, I can write 1 by tan A. So by taking LCM here you will have tan cube minus 1 divided by tan A and another expression tan A minus 1 in the denominator. So you have a cube minus b cube format because 1 can be written as 1 cube. So a cube minus b cube can be written as tan A minus 1, that means a minus b into a square plus ab plus b square. So here tan square A plus tan A into 1, that is tan A, plus 1 square, that is 1, divided by tan A into tan A minus 1. This tan A minus 1 gets cancelled. The remaining thing is tan square A plus 1 by tan A. So which is equal to tan square A plus 1 can be written as secant square A plus tan A divided by tan A. I want to split this denominator into two terms for these two terms so that we will have secant square A by tan A plus tan A by tan A, which gives tan A by tan A is 1 plus secant square A can be written as 1 by cos square A. This tan A can be written as sin A by cos A and it will be reciprocated so that you will get cos A in the top by sin A. One cos A gets cancelled and remaining thing is 1 plus 1 by cos A can be written as secant A into 1 by sin A can be written as cosecant A, which is the RHS side. Our next problem is tan A plus 1 by cos A whole square plus tan A minus 1 by cos A whole square should be equated to 2 into 1 plus sin square A divided by 1 minus sin square A. If we see the left hand side, which has bigger expressions, bigger ratios and complicated structure, consider that one. And if you observe that one, it will be like A plus B whole square plus A minus B whole square. Okay, so it is like A plus B whole square plus A minus B whole square, which can be written as 2 into A square plus B square, because the expression for this is A square plus B square plus 2AB, and expression for A minus B whole square is A square plus B square minus 2AB. So when you are summing up, minus term and plus term of 2AB gets cancelled, and you will have A square plus B square on this expression and A square plus B square in this expression, so that I can write 2 into A square plus B square. So here, if you substitute that one here according to this formula, 2 into A, here is tan A, so it is tan square A plus, and here it is 1 by cos A whole square. So from this I can write 2 into tan square A, I want to write like sin square A by cos square A plus this is 1 by cos square A, which is equal to, by taking LCM, you will have cos square A in the denominator, and on top you have sin square A plus 1, and cos square A I can write according to the identity, I can write 1 minus sin square A. So just by reshuffling you will have 1 plus sin square A divided by 1 minus sin square A. This is the expression on right hand side. Our next question is 2 sin square A plus cos power 4A, which should be equated like 1 plus sin power 4A. So let 2 sin square A as it is, and in this cos power 4A I want to make it like cos square A whole square, because in one term I have sin square A. Maybe if I expand this one I may get another cos square A, so that I can make it as unity using identity. So I put cos square A whole square, which is equal to 2 sin square A. Cos square A I can write 1 minus sin square A whole square. So after expanding you will have 2 sin square A, the first term as it is, plus it is like A minus B whole square, so you will have 1 plus sin power 4A minus 2 into sin square A square plus B square minus 2AB. So minus 2 sin square A plus 2 sin square A gets cancelled. You will have 1 plus sin power 4A. Our next question is sin A minus sin B divided by cos A plus cos B plus cos A minus cos B divided by sin A plus sin B, which should be equated to 0. So consider a left hand side. So if you take the LCM, in the denominator you will have cos A plus cos B into sin A plus sin B, and this cross terms, the remaining factor terms will be multiplied with that, so that sin A minus sin B into sin A plus sin B, it is like A minus B into A plus B, so that you will have sin square A minus sin square B plus, and here also this will be cos A minus cos B into cos A plus cos B, so that you will have cos square A minus cos square B. So cos square a plus cos square a can be written as 1, and minus, if you bring minus here as common, so you'll have sin square b plus sin square b cos square b in the bracket, so you'll have 1, so minus of 1 divided by, so the remaining thing like cos a plus cos b and sin a plus sin b. So 1 minus 1 is 0, so 0 by something is 0 only, hence the RHS side. Our next problem is cosecant a minus sin a into secant a minus cos a. It should be equated to 1 by tan a plus cot a. Since in right hand side is having some denominator but left hand side doesn't have any denominator, try to convert that one. So cosecant a can be written as 1 by sin a minus sin a into, and this is 1 by cos a minus cos a. Now by taking LCMs in these two terms, you will have 1 minus sin square a by sin a into 1 minus cos square a by cos a, which in turn we have 1 minus sin square a is cos square a by sin a into 1 minus cos square a can be written as sin square a by cos a. Cos a here and sin a here gets cancelled, so you will have only cos a into sin a. Now consider RHS, that is 1 by tan a plus cot a, and 1 by tan a I want to write sin a by cos a plus cot a can be written as cos a by sin a. Now take LCM, you will have sin a cos a in the denominator, so you have here sin a multiplied with this one, so you have sin square a plus cos a multiplied with this cos a, so you will have cos square a, which is equal to this term sin square a plus cos square a become 1, and the sin a cos a will be reciprocated to top, so you will have sin a into cos a. So both the terms concluded to one term like cos a into sin a. So from this we can easily say cosecant a minus sin a into secant a minus cos a is equal to 1 by tan a plus cot a. Our next problem is 1 plus tan a and tan b whole square plus tan a minus tan b whole square is equal to secant square a into secant square b. That is what we need to prove. Try to expand this one first. So it is a plus b whole square. I can write a square, that is 1 square, that is 1 plus tan square a into tan square b square term, plus 2 into ab, 2 into 1 into tan a tan b, tan a tan b. So this expansion over, and consider the second term, you will have tan a minus b whole square, so a square, that is tan square a plus tan square b minus 2 tan a tan b. So minus 2 tan a tan b plus 2 tan a tan b gets cancelled. The remaining thing is 1 plus tan square a into tan square b plus tan square a plus tan square b. So on our RHS side we need secant angles, so let us try to convert these tan expressions into secant. So for that I want to take 1 plus tan square a I am bringing here, and plus here I want to take tan square b as common here. So tan square b, if you take it as common, so from this expression if you take tan square b as common, you will have tan square a, and from this expression if you bring tan square b as common, you will have plus 1, which is equal to, in this I have 1 plus tan square a, in this I have 1 plus tan square a, take it as common, 1 plus tan square a into, if 1 plus tan square is taken out from the whole expression, you will have 1, and in this if you take tan square a plus 1 as common, you will have only tan square b. So plus tan square b, which is equal to 1 plus tan square a can be written as secant square a into 1 plus tan square b can be written as secant square b, hence the RHS. Our next question is 1 by cos a plus sin a minus 1 plus 1 by cos a plus sin a plus 1 should be equated to cosecant a plus secant a, which is equal to, take the LCM, it is like a, if we consider cos a plus sin a as one term and here also as one term, then it will be like a minus b and a plus b. So if you multiply that one for LCM, you will have cos a plus sin a whole square minus 1, and in top you have, this will be multiplied to here and this will be multiplied to here. You have cos a plus sin a plus 1 and here plus cos a plus sin a minus 1, which is equal to, so minus 1 plus 1 gets cancelled. You will have 2 into cos a plus sin a divided by, below you have this expansion cos square a plus sin square a plus 2 cos a sin a, and this is minus 1. Since cos square a plus sin square a is 1 from the identity relation, so plus 1 and minus 1 gets cancelled. So you will have cos a plus sin a by 2 cos a sin a. 2 into cos a plus sin a whole divided by 2 cos a sin a. 2 gets cancelled. Split this denominator to the above two terms. So you will have cos a by cos a sin a plus sin a by cos a sin a. So respective common terms will get cancelled here. So remaining thing is 1 by sin a can be written as cosecant a plus 1 by cos a can be written as secant a, hence the RHS. Our next question is, if x cos a plus y sin a is equal to m and x sin a minus y cos a is equal to n, then prove that x square plus y square is equal to m square plus n square. So anyway, we have got m square plus n square in the term which we need to prove. So consider m square from the given thing. M square is equal to x cos a plus y sin a whole square, which will give x square cos square a plus y square sin square a plus 2xy cos a sin a. 2 into ab, that's what I wrote. Now consider n square. N square is equal to, from the given thing, n is equal to x sin a minus y cos a, seems to be a minus b. So a minus b whole square can be x square sin square a plus y square cos square a minus 2xy sin a cos a. Now add these two terms. So m square term and n square term. So m square plus n square is equal to, here we have x square cos square a plus x square sin square a. If you bring x square as common, you will have cos square a plus sin square a. And here also y square a, if you bring plus y square as common, you have sin square a in this term and cos square a in this term. So plus is cos square a, and this 2xy cos a sin a, which is positive here, and here minus 2xy sin a cos a, both are same, gets cancelled. So which is equal to this, the terms which are in bracket are identities which are equal to 1. So it is x square into 1, that is x square, plus y square into 1, that is y square, which is equal to m square plus n square. This is what we need to prove, hence it is proved. Our next question is, if m is equal to a secant a plus b tan a and n is equal to a tan a plus b secant a, then prove that m square minus n square is equal to a square minus b square. This is also same as the previous one, two expressions given for m and n. So first consider m square. M square is equal to a secant a plus b tan a whole square. So I will have a square secant square a plus b square tan square a plus 2ab secant a tan a. So like that, n square is equal to, n is also have a tan a plus b secant a. By taking square, n square is equal to a square tan square a plus b square secant square a plus 2ab secant a tan a. But from the identity of secant and tan, it is secant square a minus tan square a is unity. So take minus here, like subtract this n square from m square. So by doing like that, you will have m square minus n square on left hand side, which is equal to, in these two terms, if you observe, a square can be taken, a square secant square a, and this is minus tan square a, plus a b square into, this is tan square a minus secant square a, and here this is 2ab secant a tan a and minus 2ab secant a tan a gets cancelled. So remaining thing is this much, which is equal to secant square a minus tan square a is 1. So you will have a square and plus b square into, this is reversed like secant square a minus tan square a, so that you will get minus 1 here. So which is a square minus b square equated to m square minus n square. This is what the expression we need to prove. Our next question is, if x is equal to r sin a cos b and y is equal to r sin a sin b and z is equal to r cos a, prove that x square plus y square plus z square is equal to r square. So consider x terms, square terms, x square is equal to, this will become r square sin square a cos square b, and y square is equal to r square sin square a into sin square b, and z square is equal to r square cos square a. Now we need to consider x square plus y square plus z square, which is equal to r square sin square a cos square b plus r square sin square a sin square b plus r square cos square a. From the first two terms, I can take r square sin square a as common, so the remaining thing is cos square b from here plus sin square b from here plus r square cos square a, which is equal to, this will be the identity, so that you will get 1 there. So in those two terms you have r square as common, r square is equal to sin square a plus cos square a, which in turn this is identity, so you will have 1 there, so you will have r square, that is x square plus y square plus z square is equal to r square. Our next question is, if sin a plus cos a is equal to m and secant a plus cosecant a is equal to n, show that n into m square minus 1 is equal to 2m. So anyway, we have to prove m square term. So consider m square is equal to sin a plus cos a whole square, which will give sin square a plus cos square a plus 2 sin a cos a from the expansion of a plus b whole square, which will give, this will become 1, sin square a plus cos square a is 1 from identity, so 1 plus 2 sin a cos a. I want to bring this 1 to other side because in the term that we need to prove we have m square minus 1. So bring this 1 to here, you will have m square minus 1 is equal to 2 sin a cos a. Let it be equation 1. And here also we have n is equal to secant a, I want to write 1 by cos a, plus cosecant a, I want to write 1 by sin a, which is equal to, by taking LCM and multiplying with certain factors, you will have sin a plus cos a, this one multiplied here and this one multiplied here, sin a plus cos a by cos a into sin a. Sin a plus cos a is m, that's what it is given. Sin a plus cos a is equal to m, so which is equal to m by cos a sin a. So just I want to reshuffle it, n into cos a into sin a is equal to m, or cos a sin a sin a is equal to m by n. Let it be equation 2. So from 1 and 2, sin a and cos a, instead of sin a and cos a, I can keep m by n here. So you have m square minus 1 is equal to 2 into m by n. Bring this n to that side, so you will have, it is in denominator, there it will be multiplied with m square minus 1. So m square minus 1 into n is equal to 2m. That is what we need to prove. Our next problem is, if x is equal to r cos a cos b and y is equal to r cos a sin b and z is equal to r sin a, then we need to show x square plus y square plus z square is equal to r square. So consider x square is equal to r square cos square a cos square b, and y square is equal to r square cos square a sin square b, and z square is equal to r square sin square a. Consider x square plus y square plus z square, which will give, so if you add these x square plus y square, in those two we have r square cos square a as common, these two terms. So take r square cos square a as common in those two, you will have r square cos square a, you will have cos square b plus sin square b in those two terms, and plus z square is r square sin square a, which will give, here it is 1 from identity, so you have r square cos square a plus r square sin square a, which will give r square as common, and this is cos square a plus sin square b a, so it's from identity is 1, so the remaining thing is r square, which is equated to x square plus y square plus z square. Hence it is proved. Our next question is, if cos a by cos b is equal to m and cos a by sin b is equal to n, show that m square plus n square into cos square b is equal to n square. Anyway, we are dealing with n square terms and m square terms, so first find out that m square is equal to cos square a by cos square b, and n square is equal to cos square a by sin square b. So from this I want to reciprocate this term. So 1 by m square is equal to cos square b by cos square a, and 1 by n square is equal to sin square b by cos square a. So by adding these two terms, you will have 1 by m square plus 1 by n square is equal to cos square b by cos square a plus sin square b by cos square a. So here denominator is same, just add the numerator cos square b plus sin square b by cos square a, but here you will have m square plus n square divided by m square into n square, which is equal to cos square b plus sin square b is 1 by cos square a. But that is not we need to prove. We need to prove m square plus n square into cos square b is equal to n square. So we don't have cos square b term in this. So if you reshuffle this formula, you will have m square plus n square, which should be equated to m square into n square into 1 by cos square a. So what is m square here? M square can be written as cos square a by cos square b into n square into 1 by cos square a. Cos square a gets cancelled. If you bring this cos square b to that side, you will have m square plus m square into cos square b, which is equal to n square. Hence the proof.